Okay, welcome back to the waterfall room and to our next session today. So we've got Modernizing Nubank's Kafka platform for the next 10 years. So I'm joined here by Julio Turolla and Roni Silva, who are going to be giving us this session. And throughout the session, if you have any questions, do pop them in the Q&A in Bevy. And then at the end of the session, the speakers will answer over in the Q&A there as well. So with that, I'll hand over to you.
Thanks, Kate. Good morning or afternoon, everyone. Thanks for joining in. I'm Julio Turolla. I'm a software engineer at Nubank, mostly focused on SRE. I'm currently in São Paulo, Brazil.
Hi everyone, my name is Roni Silva. I'm also a software engineer in Nubank. I've been working with Strimzi and Kafka, the current Kafka infrastructure for the last year.
Today, we're going to walk you through the evolution of Kafka at Nubank, how it works from 2014 to today, and how Strimzi was selected against multiple other options for the new Kafka platform at Nubank. Walk you through the Strimzi infrastructure, how it relieves most of our operational burden, and how we are rolling it out to an infrastructure with tens of thousands of microservices with no downtime. In the end, we are going to discuss the results and the future of messaging at Nubank. So 10 years of Kafka at Nubank. For those who don't know, which usually is most of people outside Latin America, Nubank is one of the biggest fintechs in the world. We have over 100 million customers, and we started with credit cards. Now we have checking accounts, investments, insurance, lending, and we started in 2013. Kafka was deployed in 2013 as the backbone of inter-service communication. Back then, we had like one cluster, maybe one for staging. And it was kind of a niche software back then, and it turned out it was a good choice for us. The company grew a lot. So when I joined, we had about 1.6 million customers, and we've been growing steadily and sometimes getting faster in the last six, 7 years. So in around 2019, we also went to Mexico. In 2020, 21, we started Colombia operations, and back then we had about 20 Kafka clusters, and we kept growing. And right now we are at 100 million customers. Back in 2020, the Brazilian Central Bank created a new instant transfer modality that's called PIX, and PIX became very popular. Basically, every month we have about 5 billion PIX transactions. PIX transactions are real-time transactions between financial institutions that you can transfer money to everyone or persons or businesses across the Brazilian financial system. And Nubank is a participant in from 30 to 40% of these transactions as a receiving or sending institution. And this means that 40%, 30 to 40% of the Brazilian financial system goes through the Kafkas that we manage. We have an end-to-end latency of 7 seconds to answer for a PIX transaction, and this latency we share budgets with teams responsible for fraud, for ledgers, for transactions, etc. So those budgets is met. So we keep a persistent transaction to the central bank and in HTTP, and the Nubank border servers send messages through Kafka, which send messages to dozens of services to answer if the transaction can be settled or not. That's only Brazil. We also have Colombia and Mexico with their own specificities and their own systems. Our infrastructure currently handles around 350 billion messages per week. And as you can see in this graph, we had a 2x growth over the last year. And this growth continues, and our infrastructure has to be prepared to keep up with this demand. We organize, of course, we do not have a single Kafka cluster for that, right? We organize Nubank in an organizational environment and what we call shards structure. In the organizational level, we have the countries and some internal organizations like data and internal shared tools. And for each organization, we have environments like production, staging, and for each environment, usually just production, we have what are called shards, which are copies of Nubank infrastructure that handle a few million customers. And whenever we have to scale up the Nubank system, we create shards. And how we got here? Basically, we got here with automation that created CloudFormation stacks, that created alt scaling groups, that managed that had user data, systemd, etc., that ran Docker, that ran Kafka. What's the problem of this with this setup? Well, many, right? But CloudFormation is nothing about Kafka. So whenever you change a Kafka version, there is no safe way to apply the Kafka version down there. Whenever you scale up, there is no safe way to scale up. The system is not aware of the application that's running. And when AWS terminates an instance, well, it's basically a KTLO, keep the lights on effort to make sure that things are running smoothly, and sometimes we have to jump in and fix stuff by hand. But this has a reason. When we had just a few copies of Nubank, a few shards, a few clusters of Kafka, we used it to do something that we called a immutable infrastructure. We just created a new copy of Nubank. We created a new copy with services, with Kafkas, with zookeepers, etc. And then we took the DNS and rolled that out to the new copy. That provided us an opportunity to upgrade infrastructure and scale to whatever we needed, and scale down sometimes, and that worked fine. Then we deleted the previous copy, and it was upgraded. But when we got to 50 copies of Nubank, 50 Kafka clusters, thousands of EC2 instances, it wasn't so easy for us to just deploy everything, because then we would have twice the amount on our AWS bill, and it would be very time consuming. So we couldn't keep up with this form of making upgrades. Not only that, but the fact that we had a single shared Kafka cluster per shard meant that different workloads shared the same resources, creating a noisy neighbor problem. So the PIX transactions are small and require low latency. We don't need like 10 megabytes per message for that. And even TTL, it's another internal topic, has huge messages with a lot of information, click string data, and we couldn't when we share the same brokers for this very different workloads, we ended up with higher amplitudes of latencies. So we set out to define the future of Kafka at Nubank. And we had some options. We could use self-hosted Apache Kafka like we did. We could use some public cloud offerings. There are some companies dedicated to Kafka hosting. There are companies that created Kafka, Kafka-like alternatives, compatibles, or IBM MQ. Of course, we chose IBM MQ, and that's the end. No. So with IBM MQ crossed out, we started to think about the requirements. The bank is a regulated entity. So this means that we have constraints that are not defined by us, but by central banks, for example. And there are a lot of rules on where our data can reside. And there are some disaster recovery plan tests that we have to execute every year in so we can prove to regulators that our infrastructure is very reliable. So when we have this, we really decided that Nubank's customer data should live in a cloud provider account that is owned by Nubank. And that also has other benefits. Nubank has a strong IAM system with roles, authorization for persons, and for systems. We have some InfoSec intrusion detections. We have logging, metrics, audit trail, and these are all integrated with a broader stack that allows us to create reports to identify who is using each AWS IAM action, and building all of that from scratch with another provider is a challenge. So we thought, okay, let's go to bring your own cloud. Uh, but again, bring your own cloud requires you to install a daemon that keeps a persistent connection to a third party, and this daemon has root-like access. The third-party engineers can change your infrastructure and run updates and things that are not very nice, like IAM creates roles in the daemon. So we thought, okay, let's go for cloud offering. In the cloud offering, it seems that you scale a cluster, and then it promises that it will take from 6 to over 24 hours cooldown periods, depending on the size of the cluster. And turns out the clusters are big. So and you couldn't update the clusters again until it's finished. And we have this internal anecdotal evidence. Somebody just outscale triggered, but the time for outscale cooldown period to finish was so much that it wouldn't keep up with the growth. The new size wouldn't be enough, and we couldn't do anything. So we were not super comfortable with the lack of flexibility that the solution would give us. So we really choose self-hosted. Self-hosted allows us to meet our security requirements. It reduces third-party control, and we have flexibility on config, storage, instances, networking. One thing about bring your own cloud was that all the infrastructure created, we wouldn't have like the IDs for the VPCs, etc. And we would have to go to the AWS account, fetch all this data to then create the integrations with our system. For example, creating the daemon for Bring Your Own Cloud would create a VPC per cluster. Then we would have to get the VPC, get the CIDR range, and create a VPC peering to our infrastructure, which would not be super nice. And the self-hosted has all the integrations to the Nubank platform that I mentioned. And it was obvious to us that Kubernetes would be a good building block for that because, well, Kubernetes has a lot of automated mechanisms that make our life easier, right? Just mention a few, deploying operators that manage load balancers, deploying operators that manage storage, managing DNS entries. All of this can be automated, and it's a good framework for that. And also, Nubank has a solid Kubernetes team. We have many, I have a lot of clusters. We are very good at upgrading them. So we could just use the infrastructure that our teams are super reliable on and build on top of them. So we ended up with Strimzi and a competitor operator. And when we compared both, we realized they were very different in maturity. Basically, Strimzi had solid CRD schemas, but the competitor had documentation mixing different CRD versions. We had a full JBody and EBS support, and the competitor required ephemeral instance storage. Strimzi automates most failure scenarios, and we couldn't have recovery from instance loss in the competitor. And that was mostly because there was no reattachment of EBS disks. So we had to rebalance the data, and that was not super nice. And Strimzi has a solid community and CNCF. We would be relying on a small team. And also, Strimzi has consistent release cycles. And what we noticed was that the competitor had breaking changes in the last year, which makes the lives of everyone managing software very hard. So Honey is going to jump in for some information about the messaging platform. Go ahead.
So let's walk through the decisions we made so far to build the message platform. Uh, One of the first decision was to uh, get the Kafka infrastructure that was deployed in one account to split that in many accounts. That's important context. So we have one account for origin and country, and also that's split by the environment. Next slide, please. And for sure, because of that, we had to deal with some decisions like using VPC peering to connecting some of our workloads. We decided to use VPC peering for connection that's high load and sensitive to latency, but the connection that not depend so it's not so safety sensitive to latency. We use a transit gateway. Next slide, please. And another decision we had to do is, since we are adding a new component in the infrastructure, that's the AKS clusters, we have to decide how to distribute the Kafka between those AKS clusters. And we thought that would be too much to have one AKS for all the Kafka clusters because that increased a lot our blast radius. That was not good at the past infrastructure. But having one AKS for each Kafka would be too much operational burden for the team. So we came up with a solution that's failure domains. And the failure domains is a AKS clusters that we can deploy some Kafkas on them and split them depending on the criticality of the Kafka that's running in each AKS. Next slide, please. And as we thought, as we mentioned before, we have some dimensions in Nubank. That's the organization, the environment, also the shard. And in the past, we had only one Kafka cluster per shard, but as a evolution of our infrastructure, we would like to have more Kafka cluster for specific purpose inside each chart. So we came up with the solution to create a new dimension that we are calling Kafka Flavor, and that will handle the message for specific loads inside Nubank. For example, the Pix one, a Pix Kafka to handle the Pix flow, Avalanche, that's the data stream flow, and so forth. Next, please. And on top of it, as we added many automation and so on, we were able to add some guardrails to protect, since we have a lot of automation, we have to protect from some kind of risk changes. We added a protection in SCP in the organization level, with SCP protecting any EBS to be deleted by a wrong operation. We also now have more a strong isolation of permission, since we have different accounts for each environment. And also we create some pipelines using a canary release methodology, updating first the staging and the less criticality clusters, and iterating over this deploy using smoke tests to make sure the changes are secure to go to the new clusters. Next, please. Uh, so now we have, click please. There's animation this slide, so
Yeah.
oh, thank you. So we have a modern Kafka, a lot of many new clusters that's modern, but with no deployments on there, with no data flowing through the clusters. And we need to do a rolling upgrade for that. Can you, next slide, please, Julio. So now let's discuss how we decide to migrate the data from the old infrastructure to the new one. Next, please. So at the moment, we had three options. Mirror Maker, that we found out that's really well documented, is supported by Strimzi. Uh, but for our case, we had some challenges there because we would like to have a easy rollback, depending on the situation. Also, to we have like some sensitive latency, as we mentioned, for peaks and so on. And for both cases, we found out that it would not be easy to roll back because we need to keep up upgrade in the cluster, the new cluster and the old cluster. So it would change the we need to require us to have two topic names on those clusters, and that's not so easy for us to maintain. The second option was to fuzzy clusters. Uh, that's a methodology that we already used in the past. In a few words, it's the idea to make both clusters using the same zookeeper, then make the brokers know each other, and then starting using the cruise control rebalance to move the data from the old cluster to the new one, decommission the old brokers. So that's also hard for us to hold back this because all the control will be on cruise control to manage this rollout. And it also requires us to expose the zookeeper inside Strimzi. That's not something we would like to do. And it's also hard to control the latency. So it's an option we did not felt that's not a good option for us. And the third option is using a feature that we are calling concurrent cluster.
Yeah, so Nubank has an advantage that our 1,800 microservices have all the same framework, and we use Clojure, and all of them use what we call a lib internal library called Common Kafka. And because of that, we have some control on how we can deploy new features to all the microservices. And I think one thing to notice is that we don't have anything between the microservices and Kafka. So, and we decided to stay that way because we thought it would be better to keep the same guarantees that the direct connection from Kafka to the service allows. And the concurrent cluster feature, we're going to explain it, but it's basically based on the fact that we can lose some message ordering from changing the producer to from the previous cluster to the new cluster. And that happens in three steps, where we first start consuming from two clusters, then we move the producer from the previous cluster to the secondary cluster after we run some checks. And in the end, we disable the consumer from the previous cluster so the top keeps running on the new cluster. And that's possible because we have some topic control mechanisms and we have a service just to control topics. And Honey is going to walk you through the solution.
So here are some of the components involved solution. The first one is the legacy Kafka, we call the old Kafka legacy, the new Kafka, and also the, let's call a consumer, click, actually the producer, the consumer, and also a service that's control this top configuration that's called France, and also Nuclei, that's a CLI solution we have inside Nubank. This is the current state. The producer is producing to a topic, and the consumer is connected to it. And next slide, please. We have the first step that Nuclei will send a comment to France saying to copy the config from the legacy Kafka and creating a topic with the same config in the new Kafka. That will make sure that the new topic will be able to handle all the load that the old topic will handle. Uh, Next slide, please.
So we run some checks here. We basically have to understand if the topic in the legacy cluster fits in the new cluster. So we check if we have the capacity to handle the load.
In the next step, Nucleo will send a message to France to enable the secondary consumer. And then France will send a command to the consumer. That's this example is Diablo. And then Diablo will create a connection to the new topic and starting consumer from this topic. It's in this moment, the topic doesn't have any message, but the connection to this consumer is already working.
This configuration of updates is done through a broadcast topic, which is a topic that you can send a message and all instances are listening. So we are able to broadcast an information to the entire fleet using Kafka.
In the next step, Nucleo will send a command to France, uh, saying them to swap the production from the old cluster to the new one. So the Pix receiver that's the producing this example will start producing to the top KA, but we also have some validation there to avoid some a huge amount of message being duplicated, being processed out of order on this case. So we just do the swap if this limit is on certain levels.
Yeah, there is no duplication, but if we have a lot of lag in the customer groups uh, and we change the producer, it's very possible that the new messages being produced to the new cluster arrive earlier than the messages that were in the legacy Kafka. This is not a real problem because all infrastructure is made to recover from the loss of ordering, but it can sometimes result in a burst of exceptions. And when an exception happens, another system, which is the dead letter system, handles those exceptions. So we made some checks to avoid that we overload the exception system.
And the last step is like the cleanup, and it follows the same logic that Nucleo will send a command to France and then ask the consumer to stop consuming from the old cluster and then do some validation to make sure there is no lag or message on the topic to delete the stock and free up some resource in the legacy Kafka. And this is the final state of the migration. So yeah, that's only for one topic, but Nubank has 160,000 of topics across all the clusters. And we found out if we migrate topics per day, it would take 63 years to finish the migration. If we migrate 100 topics per day, it would take 6 years to finish the migration. And if we migrate 100 topics per day, we can finish the migration in less than 1 year. And that's our target. And for that, we built a solution for batch migration that talks that's using the feature we just talked about, and with a batch manner, we are with a list of we send a list of top to France, saying to migrate from the legacy cluster to the new one. Can you click this slide, please? And all the topic in this batch will be in the state of migrating, and then once the states of all topics are okay and migrated, the migration is finished. And here are some results we have so far. Can you go to the next slide? From the 53 clusters we have now, we mentioned 15 of those clusters already running the new infra, and there are some results we are seeing in the new infra. Next slide, please. Uh, the first thing is Uh, can you click in this slide, please? Uh, we we were with some instance definition burden because we need to take some actions in the legacy infra, and that's no more a burden for the team. Next, please. We are creating at less than 1 hour instead of 1 week that was taking the legacy infra. Next. We take advantage of the upgrade to the migration to upgrade the Kafka version. So new Kafka are with newer version. Next, please. And using GitOps bring us many benefits. Like it's easier to track changes. It's also resizing disk is much simpler, and also scale up the cluster is much simpler now. Uh, and also all these mechanisms is enable the team to contribute and create clusters with the team. So that's leverage some initiatives within the Nubank organizations. This is one of our clusters. That's the data stream cluster that have peaks of uh, 80 megabytes per second. And these flows could be on the legacy infra, and it would be for sure a noise neighborhood for that topics and making some making harder to do some hair balancing the clusters because there's a lot of data there. And now it's using the new infra. That's a good result we had. Next, please.
Okay, so quick recap. Nubank Kafka's transport around 300 messages per month, and we have a high percentage of the Brazilian financial system going through them. The architecture of the current infrastructure was devised in 2014 and was very hard to manage at scale. We designed the new infrastructure around Strimzi using multiple AWS accounts, connectivity with these accounts, and the details you can ask in the chat. And we are rolling out those clusters using a custom approach that we developed using our topic management system, which is the concurrent clusters. One thing to notice is that the concurrent clusters also allows us to move topics to dedicated single tenant clusters. So we can leverage this feature to move topics from the legacy cluster to the new clusters, but we also can move from the new clusters to a dedicated cluster whenever it's possible or required by product teams. And the idea of building it as a service is to make sure that product teams can do that operation and that the guardrails and checks will be automated so they can move topics without even telling the team responsible for Kafka. For the future, uh, we expect to streamline the cadence of upgrades to keep up with Strimzi, EKS, and Kafka releases, basically upgrading us to the business class every year at least. They're gonna distribute the topics in the different Kafka flavors in a way that we can provide strict SLAs for topics that are low latency for like picks and keep the heavy lifting topics with tens of megabytes per message in separated places. We plan on starting using the operator to rebalance things. We are currently using cruise control direct through the UI. And our topic management system, it doesn't go through the topic operator. So we expect that we use the admin API for that, but we expect to add this interaction layer where our topic control system generates CRDs, and then the operator can work from there. The rollout of the platform is going well. The new clusters are always being created in the new infrastructure, but we yet to move a topic using the system. And we deployed a few clusters without crafts, and we plan on upgrading them to crafts and use tiered storage whenever it's usable. Thank you very much. We'd like to do special thanks to the team. We have people from the team that handles messages here and from all over Nubank, which helped us a lot. Daniel Marques, Márcio Moraes, Briga Lange, Didico, Bruno, Marcela, Paula, André, Navin, Jade, and Thiago. Thank you very much. And we are going to answer the questions in the Q&A.
Thank you so much. That was a really interesting session. Yeah, have a look over. There's a few questions in the Q&A, so Julio and Roni will answer them there. But yeah, thank you very much for coming and speaking at StrimziCon. And the next session will be at 4:40, and it will be on a partial multi-tenancy on Kafka using Strimzi at Little Horse.